In this next video for Chapter 8, I'm going to explore how to use the sample size formulas. It is kind of nice at this point to be able to have a way, instead of just guessing, how many people should take my survey? How many people should I involve in this study? If you have a set amount of confidence where you have to be a certain percentage sure that you have actually captured the correct population parameter within the interval that you've created, and you also have requirements for the amount of margin of error that you have associated with what's going on, because typically those are related inversely. Like if you want higher confidence, you have to make that interval bigger, and the interval gets bigger because your margin of error has grown. And so if you want to make sure that they stay in check, there is a formula that relates those two things together. So in your textbook on page 366, they do provide you with the sample size formula for quantitative data. So this is when you're dealing with confidence intervals about means. And so it basically stems from our confidence interval formula, where we know that what's on the right side of the plus minus symbol is the margin of error. And so if we tag that as ME, or just E for error, and set that equal to what it stands for, and we go through some algebraic steps to solve for N, we would end up with this formula here. So it's all they've done is a little bit of algebra to help come up with that total, or with that new formula. On page 370, you're going to see another formula that moves you into the sample size formula for categorical data, and it actually was derived in a similar fashion. You're going to take that confidence interval that's associated with proportions, which are your categorical pieces of information, and you're going to set that area, that part of the formula is to the right of the plus minus symbol is your margin of error. And so if we take that and set that equal to E for margin of error and solve for N using algebraic inverses, we would come up with this formula. This is again found on page 370 of your textbook. And so all I'm going to do is just show you how we just plug numbers into it, and then when we are finished with our calculations, we always round up to a nearest person or object, because this is the minimum. So if the minimum came out to be 12.2, then you actually need 2/10 of that next person or next object to maintain the confidence level that you've set and the margin of error that you have set. So you always want to be cautious and round up. We never round down, because then you have not met the minimums that you've set in this scenario. So I'm going to take from your book a problem just to run through this scenario. This is page 367, problem number 23. How large of a sample should be selected to provide a 95% confidence interval with a margin of error of 10? Assume that the population standard deviation is 40. So in this scenario here, we don't really know right away if we're dealing with quantitative data or categorical data, but there is a clue. Standard deviation can only be calculated with quantitative data. So that means that we're going to be using our formula that deals with our quantitative sample size. So that's going to be this one here. So I'm going to take the sheet off and start with that formula at the top. So we're going to use the sample size formula. N is equal to Z squared, sigma squared, divided by the margin of error squared. So everything gets squared. So you need to know your z-score associated with the confidence level, the same way we calculated it for confidence level. So we'll use that infinity row of the t-table. So the infinity row of the t-table will help you get your z-score that you need rather quickly. Population standard deviation and the level of the margin of error level that they are okay with in this problem. So coming back through the scenario, we had a confidence level of 95%. So we know, going back to our t-table, which is in Appendix B in the back of your book, you're going to look up the area in a single tail. So we know there's 2.5% of area left in that left tail. So that's going to be 0.025. So on that last page, you'll find the infinity row. And so our critical z we want to use is 1.96. From the problem, they tell us that our population standard deviation is equal to 40. And they tell us that the amount of error that they would like in this problem is 10. So 10 points of error. So if we just substitute those numbers into the formula, we have 1.96 quantity squared times 40 squared divided by 10 squared. And then we just need to type that into our calculators. 1.96 squared times 40 squared divided by 10 squared gives me 61.4656. And this is the exact amount of something that I need to maintain a 95% confidence with a margin of error of 10. If you have to do any rounding because they're asking you how many people or how many objects did you use, you always round up regardless of the decimal that's following that whole number position. So we don't follow traditional rounding rules because of what we're trying to accomplish. So we would let somebody know they need approximately 62 people or 62 objects in their scenario. So this was problem number 23, which is found on page 367 of the text. The next problem I'm going to do is an example of the other sample size formula. So now I'm going to use problem number 33 that's found on page 372 of the text. So I'm going to bring that in so you can see it. Problem number 33 states, in a survey, the planning value for the population proportion is P star 0.35. So that's just their notation of perhaps a sample survey that they did a while back that they're using as their gauge for what they anticipate the next group might answer. How large a sample should be taken to provide 95% confidence interval with a margin of error of 0.05. So they've come right out and told you that this is a proportion that lets you know that it's categorical data. So you should be using the categorical sample size formula. And they are asking you how large of a sample should it be. That is also going to be an indicator of which formula you should be grabbing. So we want a sample size formula that deals with categorical data. And so our sample size formula that deals with categorical data is n is equal to, again, a z star squared. Our planning proportion, which I was using p bar, but the authors are using a p star, so I'll switch to that for you. And 1 minus that same p star, all divided by your margin of error, which again is also squared. Make sure you notice that in this formula, only 2 of the numbers are being squared. The other 2 are not. Unlike in the quantitative formula, everything was to the second power. So now we just need to grab our numbers from our situation. So we need to have a z-score, we need to know a planning proportion, and we need to know the amount of error associated with this problem. They did tell us that this was a 95% confidence, and we have that z-score from our last example. It's found again on the infinity row of the t-table, looking up 0.025 as our column heading, because that's how much area would be in a single tail. The planning proportion that they told us in problem number 33 was 0.35. And the amount of area that they are okay with in this problem is 0.05. And now we're just going to substitute those values into the formula. N is equal to 1.96 to the second power times our planning proportion, 0.35, times 1 minus our planning proportion of 0.35, and all of this will get divided by our margin of error, 0.05, quantity squared. And now we just need to type that carefully into our calculators. 1.96 quantity squared times 0.35 times 1 minus 0.35, close parentheses, divided by 0.05 quantity squared, gives me 349.5856. 349.5856. And remember, this again is the exact sample size that you need. So if you're dealing with units or people, that type of thing, you want to make sure that you're always rounding up. So if they were asking us how many objects or how many people should be involved in this survey, we would round that up and say you need 350 people or units. And that's how you use your sample size formula. So the key is going to be for you to make sure you know which one of these two formulas you should be using. Should you be using the quantitative formula or the categorical? Again, one clue is going to be that the quantitative is going to supply you with a population standard deviation value, and the categorical will not. Instead, they will give you a planning proportion instead. So they'll give you a P star to use in that formula.